Hello, welcome once again. And right now we're going to be talking about chemical composition once more. But in this tutorial, I am going to be talking about concentration. And the mass concentration is of any substance in a solution is the mass of that substance over the volume of the total solution, which is in units of grams per cubic centimeters or kilograms per cubic centimeters or pound mass per cubic feet or any given combination, right? But the molar concentration is the number of moles of this component uh, in the volume of the solution or over the volume of the solution. It's mole per cubic centimeters or kilomole per cubic meters or pound mole per cubic feet or any combination. And we can go from mass concentration to molar concentration with the molar mass, right? And the molarity here is very special molar concentration. It's the number of moles, gram moles in component of the component over the volume of the solution, but in liters. So let's work with an example. Let's suppose that you have a molar concentration in a solution of sulfuric acid, H2SO4, 0.5 molar. And molar means molarity, but this is also a molar concentration. And this molar concentration is also stated to be 0.5 mole per liter of solution, okay? And it is given to you that the specific gravity is 1.03, that's for the solution, such that the density, you can express this in multiplying by the density of water, which then will yield to 1,030 grams per liter, okay? So if you want, let's say, the mass concentration, you can say that the molar mass of this sulfuric acid, you can find is 98 grams per mole, so that the concentration, but in this case mass concentration, is going to be equal to 0.5 mole per liter, and then these moles you have to turn them into gram. So you know that 98 gram is 1 mole. Okay, so this will cancel out, and then you will have 49 grams of H2SO4 per liter of solution, right? And if you want, let's say, the fraction, the mass fraction, okay, this is once again for H2SO4. Then what you have to do is, we already have 49 grams of H2SO4 each liter of solution. And you know by the density that then 30 grams of solution, it corresponds to 1 liter. This is through the density. So if you divide this 49 over 1030, you will get to 0.0475 grams of this H2SO4 per gram of solution, okay? And also very important is to express some of the traces or that are very, very small amount of components in parts per million. You just multiply the fraction, the mole fraction times 1 times 10 to the 6. So if we say that CO2 in air is 0.000375, that's its molar fraction, well, this means that it has 375 parts per million.